Hello guys. So any from any chapters, chapter 2, 3, 5, and we will talk about 6 also today. Chapter 2, 3, 5 are actually easy ones. Okay, so we are getting into more difficult things now. Chapter 5 is also based on what we have studied already. It's the vibrations basically. So only new things are Raoult's stability criterion and finding the steady state error only. Yeah, so all other things you know already basically. Only thing is extension to different kind of systems now. It is not just like first order, second order. It is now also could be first order or third or anything. But regardless of what kind of like transfer function you get, you have to write in terms of first order, second order systems, and you can solve them very easily. Yeah. So finally, they have either real root or a complex root. If the real root, this is becomes sort of first order system. If it has complex root, this becomes second order system. So that's how it goes. Yeah. So any doubt from chapter 2, 3, 5? You have quiz tomorrow, or so that's why I'm asking. Else, we will see some problems from chapter 6. Okay, so let's see some problem from chapter 6. Okay, so tutorial problem. Sorry, actually, I shared late actually, so I had that late. Those problems actually, but I got busy with something else, and I forgot that also that I had to post that. But in any case, in the last video lecture, I explained a lot of terms which you would see in these tutorials. Okay, and though based on that you can solve them. Yeah, so basically design, there's a lot of design problems. When you say design where you have to find out the value of k which satisfies the criteria. So k is a variable you plot for all k from k equal to 0 to k equal to infinity. That's what you call a root locus. And the idea is to finally select one that is going to give you the desired result. Not only select one, but also to change the root locus. So you will have compensators to change the root locus itself so that you get the desired point. So all those things. So as I said in the video lecture, there are more than one solutions for those cases. So it's not that just you get one and somebody gets something else that becomes wrong. As long as you are satisfying the constants, your answer is correct. So let's start with B61. B61. Okay, and it says root locus of GS equal to KS plus 1 divided by S square. Yeah. So this is dull root. Actually, last time we did not actually discuss. I mean, not last time, but in most of the lectures. Yeah, but in the last video lecture, I specifically talked about the double root. Yeah, so when you double root, then know what to do. So okay, so control system with this. Okay, so this is known that this will be something like this. So GS this is feed forward transfer function, and then HS is like this one, right? So when it is not specifically mentioned that this is a closed loop transfer, closed loop system, then GS HS is given by default. You will assume this. So this is minus, this is plus. Okay. So RSCS. So typically this is what the notes are, especially in your book, so you can follow this. Okay. Okay, so how to do it? This when you are going to write that basically the closed loop transfer function is that will be GS divided by 1 plus HS times GS. That's what it will be. Yeah, and hence the characteristic equation becomes 1 plus HS equal to 1, and this becomes K S plus 1 and S square. Yeah? So basically, you know that this is the open loop, or you can directly from here also you get this characteristic equation, and then you know 1 plus this, so this must be the open loop, or you can also get from this one, right? So T naught open loop transfer function is equal to simply JS times HS. Right, so this multiplied by this, we know that, right? And which is equal to K S plus 1 divided by S square. So you have the open loop transfer function based on which you are going to actually draw the root locus. Okay, so you have to follow some steps, and what steps? So let's have this. Realize this one. Okay, now S equal to 0 is the pole, and we're double pole there, so we will have 2 of them. Yeah, so remember we have 2 of them here, and then S minus 1, and then this is S minus S plus 1 equal to 0, so minus 1, S equal to minus 1. So we have 0 here, we have the pole here. Now what to do? Here you know that you can also see the angle where it will be, where it will not be. So if you have a point here, let us say, then what happens? All of them make 0 angle. Hence, here it's not possible. Okay, look at here between this and this point. If you take a point here and you draw the angle, this is making 0 degree, right? And this one is making 182, both of them 180 degree. So that means what? 0 minus 180 minus 180, so minus 360 degrees. So again, this is not possible. Look at here. Here 180, 180, and this one is 180 as well. So you have 180 minus 180 minus 180. So it becomes minus 180. So that is possible. You know that angle has to be total angle if you, because of this so basically angle rule. What is angle rule? So K S plus 1 divided by S square, which is equal to angle. So K, you can take it out. Angle, it will not take any, it will not participate in this K. So basically simply it will be S plus 1 minus angle S minus angle S, right? Has to be equal to plus minus 180 degree. Okay, and so this angle, so basically S plus 1 minus 2, because of that has to be plus minus 180 degree, and what we get is here. So automatically you have this root locus here as far as the real line is concerned. So always you are going to draw the real line on the real line first. So yeah, I'm drawing a little bit up, but actually you have to draw on the real axis itself. So you have like this. Okay, done. Now second thing, now we have to also look at that how many asymptotes it will have. Yeah. So number of asymptotes. So number of asymptotes. Okay. So n will be equal to n minus m. So n in this case is 2. So n minus m. Okay. And right, and then where n is equal to 2 and m is equal to 1 is equal to 1. So that means it will have only one asymptote, and that's why this is going to the infinity basically. So this is what the asymptote is. Angle you can find, angle will be, of course, it's the only one, so you have 180 divided by 1 only. So angle of asymptotes, angle of asymptotes equal to plus minus 180 degree, and then you can also write 2k plus 1 in this case divided by n minus m, which is equal to 1, right? So will be equal to 180 degree only. Yeah. So this is what you get. Okay, it's done. And now, but this is not complete. This is not complete because there is no root locus passing through this point. Yeah. So there has to be something there. You know. So what are we missing? So we have to find out that. Okay, and you can see that also, like when you have like let us see a point here, right here. Yeah, little bit up, just a bit up. Then what do you find? You find that at this point you have two right two of the 90 degree. There are two 90 degree here, right? So you have 190 degree because of one of the poles. Then second one also. And because of this will be 0 because it's very, very close to that. So you get 90 degree. That means there is something has to be there. There is some root locus here which has vertical like this one. Yeah. Yeah. Vertical because 90 degree, both of them are making 90 degree. Okay. So then how to find out? For that we can find out the where it is meeting the real axis, that we can find out. Yeah. Okay. So let us see. So let's we have this one. So let's erase this one. So let's also write this. Okay, so we have this one. Okay. Now, in order to find out where they meet, we can write it as dk over. I mean, there has to be. We can also find out some the break-in and breakaway points, right? So that will be the next thing to do. Break-in or breakaway points. Okay, and what do you do for that? We find out from here, right? So from here, what do we get? So 1 plus characteristic equation is 1 plus k s plus 1 over s square equal to 0, and hence you get k. K is equal to, you get minus s square over s plus 1. Right? That's what you get, minus s square over s plus 1. Okay. Now next is you are going to find out dk over ds. You make equal to 0. Yeah, and then what do you get from here? So this is how you find out the break-in or breakaway points. So dk over ds equal to 0, and hence you get dk over ds. Okay, so dk over ds you get minus 2s s plus 1 minus s square divided by s plus 1 square equal to 0. Yeah. Okay, and hence you will get simply 2 s square plus 2 minus s square equal to 0, 2s square plus 2s, 2s here. 2s square plus 2s minus s square equal to 0, and that makes it s square plus 2s equal to 0, and hence we get s and s plus 2 equal to 0, or you get simply s equal to 0 and s equal to minus 2. So that means there is a point here, right, which is minus 2, and here there is a breaking point, right? Breaking and breakaway points. Okay, and here what will be the value? Here basically what we see here is basically from here there are 2 points, they are moving, I mean they are where these points are, and hence the here it will be, here this will be the vertical line. Yeah, so the root locus will be something like this. Yeah. Because this is minus 2, it has to cross minus 2, and it has to cross this point also where it is a vertical. Yeah, and that means, and it will cross here also, this will cross here also, and hence the curve will be something like this. So you don't have to get exactly the same value, the same like circle only. Like you for in order to get what exactly this value is, you have to do more analysis. Means you have to get more the equation basically, right? So if you put for this one, if you put some equation, and then like the equation is going to give you more like how it should be. But you can also analyze basically angle wise as well. So let us say if you want to find out at this point or this point, let us say this point, which is exactly above it. Yeah. So if you want to find out what should be the value of this, okay. So just to guess how to find out whether it's a circle only. So let us say this is the point where you want to find out what will be the value of that. So let's call it this is point A. Okay, this is point 0, point A, and point B. Okay, so let's join it. This is point called P, point P. We are going to join it like this one. Now angle, remember we have all the angle criteria have to be met. Yeah, and then that really means what? That means this is 90 degree here. Yeah, this one we have to find out what, and let us say any point we don't know, but one only thing I'm saying that I want to know where this point is when this I'm keeping 90 degree. Okay, so this one is not relevant. So I although I have drawn this one because this is not a pole, right? So no pole, no, so only these two are there. Okay, so then what happens? This is 90 degree. We can easily find out what should be the angle of. We can find out others as well. Yeah. So if it is on circle, automatically what we will get, we should get this 90 degrees. So we should get 45 here, 45 there. There's no other alternative. So let's find out. Let's say this is equal to, we don't know. Let's call it. So here let's call it theta. Yeah. So then we will have this one 90 degree minus theta. Okay, and then this will be have 90 degree plus theta. Right. Okay. Now this has to satisfy the angle. Yeah. So angle. So I'm going to So at point P, we should have 90 degree. So at point P, we have 90 degree because this A point is making 90 degree. And these are two of them, right? So we get minus 2 times 90 degree plus theta has to be equal to plus minus 180 degree. Yeah? Or it could be also 2k plus 1 also you can have. Yeah? So this is the what we have to find out. Now looking at this one, what do we get? We get 90 degree minus 180 degree minus 2 theta, yeah, is equal to plus minus 180 degree. So let's say k equal to 0. Yeah, okay. And so let's take the minus sign. Okay, we'll just pick up minus sign. So we'll get that. Okay, so 90 degree minus 180 degree minus 2 theta is equal to minus 180 degree, right? And then what you get? You get 2 theta equal to 90 degree, and you get theta equal to 45 degree. So what do we get? It tells you that when when you find out, you want to find out a point on the root locus, which is exactly over the 0, that will happen only when theta equal to 45 degree. Yeah, so this is 45 degree, so this is also 45 degree. Yeah, so that tells you that this must be arc. Yeah, you know, and hence you can analyze all points. All points you can analyze. So you can find out that this is a circle only. There's no other way. Yeah, so this is, since this is a graphical method, you can do graphically more. You can find out that way. Yeah, so this is how it will look like. So there will be one line, it will go to infinity, then it will be a circle, it will look like this. Yeah. Any question, guys? Okay. Okay, so let's see more problem. So basically, you have to see the videos, otherwise it will not make sense. Yeah, so I already taken a lot of examples in those lecture videos. So all concept we have studied there using some examples only. So there is some general steps, but examples are given. So that is going to help you. Okay, so I'm seeing the comments. So first comment by Ayush, once confirmed that we used open loop for poles and zeros and then use closed loop to find locus. Okay, so okay, so regarding the closed loop and open loop, this is true that what you do, like all the poles and zeros that you draw are for open loop only. Okay, so you use open loop for poles and zeros and then use closed loop to find locus. Yeah. Okay. Yeah, so that is true. Yeah, so for closed open loop transfer function is given already, right? So open loop transfer function is given, and there is nothing which is not known. Yeah, so what is unknown is just k basically. Otherwise, it's in the previous example. For example, you have t naught s equal to s plus 1 and then k. Yeah, and then right? And then you have S square. So in this case, only K is unknown. K unknown. Why unknown? Because this is a design value, right? Need to be found out. Okay, suitable value you need. So typically, when you design it, you need to find out a suitable value basically. Yeah. So hence you have the value which is given here, but the K is given here, but you need to find it out. So here the whatever the points you draw, that is based on the open loop, but finally you have to find out the roots of the closed loop system, and hence you vary K and you find out. So that is true. Ayush is gone, although he asked. Sorry, I think I did not see, so when I asked that, I did not get the comment. So maybe you gave comment later, so I did not see it. Okay, so but you are right. Okay, so now next, what is the difference between the break-in and break-away points? Okay, so break-in and break-away points. So draw something. You go from K equal to K equal to 0 to K equal to infinity, right? So you draw. So K equal to 0 will be at the poles. K equal to infinity will be at the zeros, right? So basically, you go from here to here. So break-in points basically breakaway points, meaning that when it's come here, so this break-in, right? So when it's approaching, then you are increasing K equal to 0 to, let us say you have like this. So K equal to 0, so it will go to some value. So this is breaking in. Then break away means it will be away, it will going away from it when you increase the K. So this is measured in terms of K value. Right? So while increasing the K value, first it will come and then emerge out of that. Right? So both are the same thing basically. Yeah, refers to the same point. Right, that is correct. Yes. But sometimes it may be possible that particular point it may be emerging out. Yeah. So let us say this is a pole here. Let us say, yeah, 0 here. So from here also it will go out. Right. Let us say it is going out like this one. So there is no break in here. This is a breakaway point only. Yeah. So that may be like that also. Yeah. So when you have sorry, this is a cross here. Yeah. So when you use a pole, let us say there is a pole here like this one, double pole. There is somewhere double pole is. So like here, see, there is double pole here, right? 1 over s square. T naught s equal to 1 over s square. If you draw this, then how will it look like? T naught equal to k over s square. So you have like k equal to s square, and then what happens? Your value it will go like this. Yeah? So here basically this is breakaway point only. There is no break-in point here, right? So it is just going like this. Yeah. Yeah. Okay. Yes. So depending on the situation, sometimes you may have only break-in or breakaway. Sometimes both of them may also be there. Yeah. Okay. So is it clear now? How will we make the flow arrow? Flow arrow typically you can make based on the how you are changing the K basically. right? So as I said, you start with the arrow value will be in the direction of increasing k, basically. Yeah, typically you will not see even drawn somewhere. Yeah, so like in your book it's not drawn, that there is no arrow. Yeah, but I think it's a good idea to show how when k is increasing, which way it is going. Yeah, so I show it like this one because this also is convenient. It tells you how the k is changing, basically, when the increasing. So you can show the arrow in the direction of increasing k. Okay, just a minute. So only I was talking about, okay. If a single pole is there and no root locus nearby, so we will reject that point. Single pole is there is no root locus. No, I did not get you actually. Only pole is there is no root locus. No, if there is only one pole, it should look like this one, and then there will be root locus. There will be something. If it will be something like this. If there is a single pole, right? So that means it could be like a open loop transfer function will be something like that. E naught s equal to 1 over k over s plus a. This will be something like this, and hence how will you plot? You will plot s equal to minus a, like this one, and here the pole is like this, and hence your root locus will look like this. Yeah, because 180 degree only one, but it is making 180 degrees, so it will go towards infinity. It will go. Yeah, so if a single pole is there, okay. Eighth question. Just a minute. Eighth question doesn't have a single pole. If a single pole is there and no root locus nearby, so we will reject the point. That point. Okay, let me see. Okay, so okay, sure. Okay, now 6, 8. Okay. I'm going to solve that also. Okay, so let's see the next one. So root locus is little bit difficult part. Okay, so you have to do practice, basically. That is needed. Yeah. So B68. Yeah. Okay. And here we have consider unity feedback control system with the following feed forward transfer function. So we have feed forward transfer function. GS is equal to k divided by s square plus 4s plus 8, right? And hs equal to 1 because you need this is unit feedback control system, and hence you have T naught S is equal to K over S square over 4S plus 8. Okay, so first of all we are going to plot the root locus for the system if the value of gain K is set equal to where the closed loop was located. Okay. Now we have to find out for K equal to 2, poles equal to what? So for the closed loop. Yeah, so closed loop poles, the closed loop poles. closed loop poles go together. Okay. So K for S square plus 4S plus 8. Okay. Now we start with we can identify all the poles. So to start with, we have S square plus 4S plus 8 will be equal to S square plus 4S plus 4 plus 4, which is equal to S plus 2 square plus 4, and is equal to S plus 2 square plus 2 square is equal to S plus 2 plus I2, yeah, and then S plus 2 minus 2I. So, okay. So hence our poles we find out poles is 0, and then we have minus 2 minus 2I and minus 2 plus 2I. Yeah. So we have this situation, right? So how do you draw? You draw like this. Okay, and then you have 0 here, so we mark the cross here, and then minus 2. So let's say minus 2 is right here. Okay, little bit here, let's say here. So we have here and here, right? So we have one cross here, like this. Yeah, and this is minus 2. And this is also from here to minus 2, from here to here also minus 2. Yeah, so this is also minus 2 here, minus 2 here. Yeah, okay. Now next we have to look at this. Let us say at this point whether it will be there or not. First we start from the right, basically. So at this point, if you see, if you draw from here, from here, they will cancel out. Yeah. So you have this angle and you have this angle. Both of them will be 360 degree. So it will not this and this both will be 360. This is also 0. So this is not possible here. This is possible here. Let's say at this point. So 180 degree. This will be this angle and this will be that angle. So both 160 degree, this and this, if you add 180 degrees, so there is possible. So what you have is, in this case, your root locus will go like this. Yeah? So one will go like this one. Yeah. Okay. Now next thing, this is done. This will be on the real axis. The first thing you have to do, draw on the real axis, and hence you have that. Now we don't know about this one yet, so how to do that? So next thing will be to find out the number of asymptotes, right? So number of asymptotes, okay, so will be equal to n minus m, and here m equal to 0, n equal to 3. 3 minus 0 equal to 3. So 3 of them we have. Yeah. So, and you know the angle for that, right? Angle of asymptotes, right, will be equal to 100 plus minus 180 degree. Yeah. And 2k plus 1 also you can say, and divided by n minus m, which is equal to 3. That really means you get 3 of them. If you work out this one, you get plus minus 60 degree, and then 100 and 180 degree as well. Yeah. So for k equal to 0, you get plus minus 60 degree. K equal to 1, if you put, then you get 180 degree. Okay. So there are 3 possibilities. So like this one, and then there will be like this and like this. Yeah. So this is 180 already there. Okay. Now the points, we have to find out where those asymptotes are, right? So the common points of asymptotes, right? So common point of asymptotes. And how do we find out? So just we look at the real path of that, right? So as we did earlier, so we have the minus 2 real path of that. This is also minus 2 real part of that, and then minus 0. Okay, all are poles only, so minus 0 also, right? So minus 2 minus 0, Okay, and divided by, we have 3. So we get minus 4/3. Okay. So minus 4/3, which is equal to minus 1.333, right? Okay, so this will be somewhere here, let us say close to this one here. So it says that this is going to be, this is going to common point, right? And from here, what we are going to do, we are going to draw 60 degree from here. Yeah. So I don't know where you're going to meet. So it will be like this, 60 degree. Let us say we are drawing this 60 degree, 60 degree and 60 degree both, plus minus 60 degree. Okay. Now these are going to be asymptotes that we know, and it is meeting here. Which point is that? Which is minus 4/3. This point. Okay. Right. Now these things are done. Now we have to find out the break-in and breakaway points. Yeah. So let me do this one. Okay. So break-in, breakaway points. Okay, and for that we have to find out k, right? So we have 1 plus k s square plus 4 plus equal to 0, and hence we get k equal to s square plus 4s plus 8 equal to 0, right? Okay. Okay, just a minute. Can we extend it to? So how will we decide whether to go up from the above point or below, as my angle of departure is coming minus 45 degree? How to know whether you go up or down? Here basically it goes, remember the root locus is symmetric about the real axis. It will go both sides. Yeah, it will go up and down both. Yeah. Yes, Aditi, you got it. So this is symmetric about the root locus will be symmetric about the real axis. So hence, like if it is going up, it will go down also. Yeah, got it. Yeah. Okay. Now this we get dk over ds is equal to d over ds, and then we have s cube plus 4s square plus 8s is equal to 0, and then we get 3s square plus 8s plus 8 equal to 0, 3s square plus 8s plus 8 equal to 0. Hence, from here we can find out s equal to minus 8 plus minus root b square minus 4, 3, 8, 6. Yeah. From which point to go which side? I'm not getting you somehow. Okay. So from which point to go which side? So that we have to see basically. Yeah. So we have to analyze. So that's what it is. Like it will go to infinity. You know that there are three. What you know here is there are. Oh, you are asking probably this one, whether it goes upside or downside. So it will go up, right? Here it will go up, here it will go down. So what is the mean? It should go like this. It will go like this. Why? Yeah, okay. Yes. So, okay, if your question is that it will go up and down like this. Why? This is because, first of all, it should start from the pole, and hence starting from the pole. Second thing is that these are asymptotes. That really means that they have to go to infinity. Asymptotes are used for something which goes to infinity, right? So here it is tangent there. So this is asymptotes, hence it has to go to infinity because the poles are at infinity. So number of poles, number of zeros in infinity equal to n minus m. Yeah, so one zero in infinity. Zero in infinity meaning that if there is a difference the two, then you can take it number of, that's why it is a number of asymptotes really means that there are how many curves are going to infinity, that really means. Yeah, so in this case, therefore three curves will go to infinity. So one is going this infinity, other from here it will go up, from here it will go down to infinity. Okay. Why to plus infinity only for this, and why can we go to minus infinity for this one? Okay, so you are right. Basically, we may get, that is correct. It depends on what we get here. If break away points, if we get something is real, then it may come down also. It may go like this also. Yeah, depending on whether we are getting the breakaway point or not. Yeah, so this I just said. Finally, it has to go like this one, but it's possible that it's moving like this and goes like this, or from here it moving like this and goes like this one. What will tell you? Breakaway points. If you get breakaway points, which is a real number, that really means it is going to cross the real axis. If it is not a real number, that really means it is not going to cross. Yeah. Okay. So we can check it out here. Yeah. So what we have here is s equal to minus 8 plus minus root 64, and we get 96 here probably, right? Okay, we have 6. So what we get is not a real number. Yeah, so you can see this is we are getting imaginary number. Yeah. Okay. So this is a minus number, and hence this imaginary number, and hence that means that breakaway points are telling you is not possible. Yeah. So it is not. So this is not. That really means not intersecting the real axis. Means there is no double root. That really means there is no repeated root. That tells you, in this case, this point, on this point there is there's no repeated roots because they are not crossing each other. So that's what it tells you. So this is how there is no real number which is a the common point, and hence it should go up and down like this. Yeah. Okay. For 1, it has to go to plus infinity, yes, and yes. So 1 has to go to plus infinity, 1 has to get to the minus infinity. Yes, that's true. Okay. Any other doubt? Here, angle of arrival departure you can find out. You must have done always. You are saying you are getting 45 degree. So yeah, so what you have to do is you find out the angle. Yeah, so yeah, okay, minus 45 degree. Yeah, so that really means it will go like this. It will go like this from there, like this. If you get 45 degree, then it will go a little bit like this. So you have minus 45 degree like this. Plus minus, you must have got both, plus minus both, plus and minus 45 degree. So this for this you will get minus, for this you will get plus. So then you will get like this one. So got it. I have not calculated. Yeah. So but, since you are saying, I am writing it. Yeah. Any other question? Okay. Okay, then time is up also. Okay. Okay. See you next week now. All the best for your exam, everybody. Okay.